So plugging into the quadratic formula, have this. Oh boy. So pull up my old calculator later. See you later, calculator. Oh, that's a funny joke. Or not, I don't know. It's the end of the day. I'm kind of slap happy by now. You ever get that way at the end of the day? Always. Then you feel my pain. All right. So I'm going to type this in all in one big shot because I'm calculator confident. But I like to use the fraction command because it helps deal with some of those parenthesis issues. So there's my negative 30. Oops. Yeah, negative 30 sine 70. And I'll do plus. And then square root 30 sine 70, close, close, squared, minus 4 times 16 times 5, all over 2 times negative 16. So that value for t is negative. That's not the value of t we want then, right? So all I'll do is press second and enter, and I'll just go back in here and edit that plus to a minus, and we get 1.6. So using that, I'm then going to do x of 1.6. I guess before I get going too far, I just want to, oh boy, look at what I didn't check on. Oh dear. Let's do that one more time. Okay, 192. Good thing I checked, right? We all make mistakes. Everybody forgets sometimes. At least I thought to go check, though. I could have gone through and then checked my answer and been like, well, that's not right. What happened? You know, we could have been sitting here all for a long time with our fingers up our nose going, dur, 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 what happened? So when I type that in, I get 19.74-ish feet, which is greater than the 16.5 that was the end of my circle. Oh, wait a minute. Was that a radius or a diameter? Okay, 18-inch diameter. Good. Okay. So too far. I overthrew. I missed it by a little over 3 1/4 foot, or a little less than 3 1/4 foot, which is quite a lot, right? Hopefully the person waiting to go next wasn't standing near behind the circle, or they might have gotten a lawn dart in their leg. That's an old game, though. They used to, like when I was a little kid, everybody had this game. They stopped making it because people were getting hit by lawn darts and hurt. You know, you take that to an outdoor barbecue or whatever and people have been drinking, it's not a good combination. Lawn darts were rather heavy. Therese, you feel good about what we did there, though?
Yes.
Okay. Yeah, no problem. Anybody else got something from the homework set they want to talk about before we move on? Okay, well, if you guys change your mind, we can always come back and do some more next time, right? It's not like the book is closed on these guys. So if you decide you want to come back and talk about some more of them, we can certainly do that. So today, we're going to be talking about polar functions. So our tools that we're going to be using when doing these problems with polar functions are going to be that are kind of these three tools. So let's say we have the polar function 6 cosecant theta. Let's say we want to look at the graph of this. So one way we could do that is we could graph it on our calculator. So to graph a polar function on our calculator, we need to change our mode from function or parametric mode, which is likely where your calculator was, into polar mode. So I'm going to go ahead and change that. I'm going to go put this back into radian mode, because if we're graphing, I'd rather go from negative 2 pi to positive 2 pi or something than have to go from like negative 360 to positive 360. Yikes! Okay. So I'll go to my y equals menu. So here you notice everything starts r equals, and I'll do 6 divided by sine theta. Remember that cosecant is 1 over sine, so that's why 6 cosecant theta turns into 6 over sine theta, right? I'm just going to go double check my window real quick to make sure it looks reasonable. 0 to 2 pi is fine. Let's just do a standard window, maybe negative 10 to positive 10. And same thing on my y's, negative 10 to positive 10. And then hit a graph. Well, that's pretty stinking boring, right? Why would that be so boring? Well, let's examine. Let's try converting this into rectangular form. So like we said before, we can say that this is the same thing as 6 over sine theta, right? And if I multiply both sides by sine, I have that r sine theta is equal to 6. Okay with that? Notice that, oops, gorsh, Mr. Kulik, that y is the same thing as r times sine theta. So in rectangular form, this is literally just y equals 6, which is exactly what we're seeing on our graph, a horizontal line that passes through the y-axis at 6. Oh. Okay, well, that's not very exciting, but okay. What if we had our cosine theta instead? So I'm going to go back to my graph and just change that into r times cosine theta, or 6 cosine, r equals 6 cosine theta. And then let's hit the graph and take a look. Woo! That's pretty exciting. So I get this neato circle here. Let's see why that's the case. Let's try to convert this into rectangular form. Okay? So I notice that this looks like a circle, right? My graph. Who remembers the general form equation for a circle from their geometry course? Nobody? X minus h squared plus y minus k squared is equal to r squared, where hk is the center of our circle. You guys, does that ring a bell? Okay, well that's the general form equation for a circle. You probably did it briefly at the end of your geometry course. You might have been a little checked out by then. That's okay. It was 2 years ago that you would have seen it. Yeah. But since the graph that I'm looking at is circular, there's a good chance that this is going to be the key that I'm going to need. So I'm going to start trying to transform this into what I'm looking for. Okay? So I'm going to first start by multiplying both sides of my equation by r. And then I know that r squared is equal to x squared plus y squared. So far, so good. And then r cosine theta, what is that? It's just x, right? Remember our things at the beginning? That was one of them. X is equal to r cosine theta. And now what am I going to do? Well, I'm going to subtract that 6x over. And I'm going to do completing the square. You guys remember how to do completing the square? That was something you would have done last year in your Algebra 3-4 course. Okay. So I abbreviate that as CTS. So let's do this completing the square kind of once generally for like some general quadratic, and then we'll do it for this specific one that's going to be much easier. But we'll do it once as general so that it's like you can see all of the things that you might possibly have to worry about. So the first thing is that we want to make the leading coefficient 1. So I would start by factoring out the leading coefficient. Everybody okay there? Then we're going to add and subtract the null term divided by 2 squared right in a row. So note here that b over a divided by 2 is just b over 2a. Right? Because if you multiply by the reciprocal, it's the same thing as dividing, right? Okay. So I have so notice what what this is really right here? It's just 0, right? So I still haven't done anything, really. I've just added 0, which, who cares, right? Is that okay? So the trick now is I'm going to distribute the A to that piece to kick it out of the parentheses. And this piece here now is a perfect square. So you remember, let's use letters that we haven't used yet. How about M and N? So this piece in green, by definition, is a perfect square. So it's just going to factor down to x plus b over 2a. And then my squared on the outside. And then I have all this other junk left over. And we're done. Woo! Okay. So that's just like a little aside. Let me just kind of bloop bloop that over here. So if we just have x squared minus 6x and we want to complete the square on this, the leading coefficient is already 1, right? Well, that's handy. What do I do next? Well, I'm going to have to add and subtract negative 6 divided by 2 squared to both sides, or not to both sides, but everybody good with that? And let's go ahead and simplify that. That is my perfect square. It just factors down to x minus 3 squared. Is that okay? Okay. So what I have now is I have x minus 3 squared minus 9 plus y squared equal to 0. Is that okay? Because I've replaced this piece with that piece, right? You kind of see the reasoning now. It's a little jumbled because I did that big completing the square review there in the middle. But if we just add 9 to both sides now, this is a circle with center 3, 0. Because I can think about y squared as just like y minus 0. And if we looked back at our picture, it's exactly what we had, right? Let's do another one. Sound good? Yo. Yeah, you can walk even if you want. There's no rush. Or maybe it is a rush. I don't know. Like, I don't want to presume your bladder situation, you know? Is it embarrassing yet as I talk about people's bladder situations? I hope not. It's not intentional to try to embarrass anybody. Okay, let's do the same thing again. We're just going to convert this into rectangular coordinates. Before we get started, let's graph and see what this looks like to give us a little bit of intuition about where we're headed. Okay? So it's often going to be helpful just to get a picture of what it is that we're supposed to be getting, so it gives us a little bit of insight about where we're going and what our end product should look like. Okay, so again, we're getting something circular, and the center appears to be somewhere here in the second quadrant, right? Everybody agree with that? Again, quadrant 1, 2, 3, 4. Okay. Well, I'm going to start the same way. Let's multiply both sides by r. And then apply some of our identities. So r squared is x squared plus y squared. R cosine is r sine is y. And then we can move everything onto one side. Oops. Minus. So far, so good? Okay. Oops. Y squared. So now I'm going to complete the square for each of these. I'm going to complete the square for x squared plus 5x, and then complete the square for y squared minus 4y. Okay. And then I'm going to kick that guy out. And I'm going to kick that guy out. So far, so good? I'm going to go ahead and do my perfect square factoring on each of those. Denominator. So I can combine those two fractions and move them to the other side. So we have a circle with center negative comma 2. That looks like the right spot to me. And whose radius is 41 over 4, which is about 6 or, 6 inches. Right? 41 is between 36 and 49. So it should be somewhere between square root of 6 or between 6 and 7. I'm guessing about 6.5. I don't really know. That's just me ballparking it. But that matches pretty close to what we saw in our picture, though, right? Okay. Let's do another example. Let's do one going the other direction, though. So let's go in rectangular form and turn it into polar form. So let's start with something easy, like y equals 4. So I know that y is the same thing as r times sine theta. Okay with that? That was one of our identities that we listed at the very beginning, right? And then I can just divide both sides by sine theta. And that's the same thing as like 4 times cosecant theta. Keaton, you stretching or questioning? Get your stretch on, brother. That's it. So that one's no big deal, right? What if we give you something like this bad mama jamma, though? What shape is this going to be? Should be able to look at it and tell. Circle. Good. So what I'm going to do is I'm going to first begin by foiling everything out. Now remember, x minus 3 squared is not x squared plus 9. Exponents do not distribute, right? That's the same thing as x minus 3 times x minus 3. So that's what we get when we FOIL it out. Is everybody okay with that? Don't make that mistake. It's an easy one to make. In math circles, we call that the freshman's formula. When people say a squared or a plus b squared is a squared plus b squared, because it's a mistake that a freshman would make. So, anyways, don't be a freshman. So what I'm going to do now is eventually I want to get an R here, right? If I want to get a polar equation, it has to start R equals. I remember back to my identities that x squared plus y squared is R squared. I have an x squared and I have a y squared. So I'm going to just take everything else and dump it onto the other side. So I added the 6x over, subtracted the 12y over. I subtract 9 from 45. That gives me, it just gives me 0. That gives me 36, and when I subtract the 36 over, I get 0. So far, so good? Okay. So apply some identities. X squared plus y squared is R squared. And then x is the same thing as R cosine theta. Y is the same as R sine theta. We're real close, right? This should start R equals rather than R squared. So what do I need to do here? I don't want a square root. I want to divide by R. But Mr. Kulik, we never want to divide by a variable. Why is it okay to divide by R? What is R? A radius, right? The radius. Can the radius be 0? No. So dividing by R is okay because we're not actually ever going to be dividing by 0. The radius is a non-zero quantity, so it is okay for us to do that. And then we can check here. Let's type this into our calculator and take a look at the circle that we get to make sure it's something whose center is at 3, -6 and has a radius of around 7, right? So 6 cosine theta minus 12 sine theta. Okay. So 3 over, 6 down, looks like about the right spot for the center. Radius, that looks like about 7 to me. Looks pretty good. What do you guys think? Let's stop here. And there's no homework for you guys to do on this section without the next section, because any of these problems involve also identifying the form and type of graph, and we haven't talked about that. If you were really feeling oh, never mind, we could do those problems. Oh, I know. It's exciting, isn't it? So, again, you guys could do just the convert for these ones. You can't do the other half where you identify the type of graph, but you could definitely do to 84. But guys, we're so close. This chapter's only got 96 questions. You've already done 62 of them, though. I know, I'm sorry, guys. What? I still couldn't hear what you said, but that's okay. It's I probably didn't want to hear it, did I? Probably not. But it, like we're done.